Hello, and how are you? Welcome back to mathematics. My name is Joel Muthia, teacher of mathematics and physics. But on YouTube, I always teach mathematics. Now, today we are looking at the area of assignment. This lesson has a connection with the lesson that I taught earlier, that I've called it part 1, which is the area of a sector. If you are here now looking at the area of assignment, it is advisable you first of all visit my previous work about the area of a sector. Look at part 1, area of a sector. Now, if you have watched part 1, let's look at now the part 2 of the question or of the lesson, which is the area of a segment. Now, I'm going to draw a diagram here so that we may understand really what is a segment. So I'll draw a circle here like that. Then I'll have the center. Then now I'll try to join the center to two radii. Then I'll say this is the radius, and now this is the radius. Then I'll draw another line which joins the two parts of the circumference, which we normally call it a chord. So this is a chord. You can name it and call it what? A chord. A chord is a line joining two parts of the circumference. The greatest chord, or the largest one, is called the diameter. Now, remember, last time we said this region bounded by two radii and an arc. An arc is part of the circumference, like I said before. So, the area bounded by two radii and an arc is called what? A sector. It's called a sector. And the two radii will always subtend an angle theta. Now, the region bounded by a chord and an arc is now what we call the segment. It's called a segment. Area bounded by a chord and an arc is called what? A segment. So this one, I can really call it what? A minor segment. I can call it a minor segment. Then the other part, which is remaining now, is also bounded by what? This chord and this major arc. So I can call it this one a major arc. So this region now, we will call it what? The major segment. The major segment. If you look clearly, you will realize that this segment is inside the sector. And if you use this sector, if you remove this segment from the sector, you are going to remain with a triangle. So inside this sector, we have a triangle and a segment. So if actually you need this segment, you will take the whole area of the sector, then subtract the area of this triangle. But first, let's define what is a segment. And I'll say segment is a part of a circle, which is bounded by what? Which is bounded by chord. By a chord and an arc. Bounded by a chord and an arc. Remember, we have said if you want this segment, this one, you must take the whole area of the sector and you subtract this triangle. So if you want the sector, if you want the segment, is simply, this is the area of our segment. You must take now area of sector minus the area of a triangle. The area of the triangle. So now the area of the segment we will be given by the formula. Last time we said the sector is given by theta over 360 pi r squared. So we will say it is theta over 360 pi r squared. Subtract the area of a circle, which is simply given by half times base times height. Where is this base? The base is the chord, and the height is the perpendicular height from the center. This now will be our height. So when we will be solving some questions about the segment, we will be required to calculate this height. Now we have the radius. Radius are the sides of this triangle. Now it is very simple. Get the area of the sector, then subtract this triangle. You will remain with this segment. Now, can we look at one example about the segment? Let's look at this one. Find the area of the segment. Segment is this shaded region here. So we will start by writing the formula, and we say the area of the segment is simply the area of the sector. The sector is given by theta over 360 pi r squared. And subtract the area of this triangle, which is half base times the height. So we want to substitute what we have in this question. But before, let's look at this formula. Do we have what we need? Let's look. Do you have theta? Yes, theta is 81 degrees over 360. Do we have pi? Pi is always given by, pi is always 22 over 7. Then let's look at the formula for the triangle. Half times base. Base, we said it is the chord, which is 13, times the perpendicular height. Do we have the perpendicular height, which is supposed to be here? No. So we will first of all calculate the perpendicular height of this triangle. So now, if you take a section of this triangle with the perpendicular height, you will realize that if you drop a perpendicular height here, it will divide 13 into 2. So at this point we will have 6.5 and this other point is 6.5, and we will form a right angled triangle. So if I can draw this right angled triangle here, this now will be 6.5 centimeters and this is 10 centimeters, and we do not have the height. So this height, we will use what we call the Pythagoras theorem to get the height. So we can just name this side as A, this side as B, and this side as C. Pythagoras theorem dictates that A squared plus B squared is equals to C squared. Let's replace what we have on this formula. What is our A? A is 6.5. So you write here 6.5 squared plus our B is now the height. So we will say H squared will give us what? Our C is the hypotenuse, which is 10 squared. If you want to remain with the H square here, because it is what you are looking for, you can take this one to the other side. And now we will have h squared should be equal to 10 square minus 6.5 squared. So our h square will be equal to what? 10 square is 100 minus 6.5, you can use a calculator, 6.5 squared, get what? 42.25. We subtract 100 minus 42.25, you get 57.75 as h square. So take the root of both sides and our h will be 57. If you take the square root of both sides, you can take the square root of the answer, which will give you our h as 7 point. If you round off to one decimal place, you will get 7.6 centimeters. You are going to get 7.6 centimeters. Now we can continue with our question here and say now we have the height. You can really look at our question. Remember we said that the area will be given by theta over 360 pi r squared minus half the base times the height. So looking at our question, we did not have the height. So we calculated the height and got 7.6. So let's replace what we have in this question. So we will say the area will be given by theta is 1. So you will say 1 over 360 times pi, which is 22 over 7, times the radius, which is 10 times 10. Can put that one in bracket. Minus half times our base is 13. So times 13 times our height. Our height we got what? 7.6 using Pythagoras theorem. And now you can also put the bracket. So let's simplify the first part. First part of the sector. So if there's nothing you can simplify, but you can just simplify this 0 with this 0. Then you have by 2, 11, and by 2, 18. So now let's use a calculator. There's a simple way to multiply the fractions using a calculator. You can just say it is 81. There's a button written as ABC here. This is the ABC, which writes a fraction over what? 18. Then you multiply by 11, ABC over 7. Then you multiply by 10. And you multiply by 10. So at this point, you just click the answer. It gives you 70 and 5 over 7 as a fraction. So if you want a decimal, you just click this button written ABC. So if you click it, you will get what? 70.71. So we write 70.71 centimeter squared minus, let's look at this one, which is half. So we'll say 1 ABC over 2. Then you multiply it by 13 and you multiply it by 7.6. You click the answer, you get 49.4. Just subtract them. This is centimeter squared. You subtract them, 70.71 minus 49.4. Click the answer, you get what? The answer is 21.4. 9.31 centimeter squared. So that is the area of that segment. So to avoid confusion, this is the question we were dealing with. We are finding the area of the segment. Segment is this shaded region here. And you can say it's the area of the sector theta over 360 pi r squared, then minus half base times height. But we did not have the height, so we had to extract this triangle, and using Pythagoras theorem, we could get the height at 7.6. After getting the height at 7.6, now we replace this one on our formula. Theta is 81 over 360 times 22 over 7 times the radius, which is 10 times 10, minus half times base of 13, then multiplied by the height, which was 7.6, and we got 21.31 centimeters squared. Now we can try to solve the third example here. The third example is find the area of the shaded region. So let's look at this second example of the area of a segment. If you look at the shaded region is a segment, and you calculate the area of a segment. Area of a segment is given by the area of a sector, which is theta over 360 pi r squared, minus the area of this triangle here, which is half base times height. Some of you are asking, which is the sector? The sector is the whole thing from part 1 of the question. Now let's look if we have everything. Do we have theta? Yes, it is 120. Do we have pi? It is 22 over 7. Do you have the radius? It is 14. Minus, do we have the base? The base is here of the triangle, which is 20 centimeters. Do we have the height, the perpendicular height? No, we do not have the perpendicular height. So we are going to look at the perpendicular height. We will extract this one. If you drop this one, you are going to get this as 10 and the other one as 10. Take one of the triangles, it will look like this. This is 14, this is 10, this is our height. So this is A, this is B, and this is C, according to Pythagoras theorem. Pythagoras theorem states that A square plus B square is equals to C square. Let's replace with what we have in the question. Our A is 10 centimeter. So we'll say there is 10 square. Plus our B is the height that we do not have. Is equals to our C, which is 14 square. We only want to remain with the AH here. So you take 10 to the other side. Here it was positive. When it comes here, it becomes negative. So here we remained with h square, which is 14 square minus 10 square. So our h square will be equal to what? Feel free to use a calculator. So we have 14 square minus 10 square. So you just key in 14 square minus 10 square. And you click the answer. Get 96. Get 96. Wanted to remain with h here, so you take the square root of both sides, and you will realize that our h is equals to what? Take the square root of 96, square root of 96, and you get 9.797. Round off to one decimal place, you get 9.8. You get 9.8 centimeters. Now that we have the height. Now we can back to our formula here. We can now replace what we have in this formula. Remember, we said the area of our segment is given by the area of our sector, which is theta over 360 pi r squared. Then you subtract the area of the triangle, which is a half base times height. Looking at our question, we can say our theta is 120 over 360. Multiply it by pi, which is 22 over 7, times the radius, which is 14, and it is square, so it is 14 times 14, minus a half times our base is 20 times our height here was 9.8, so you can just say 9.8. So simply you can say is equals to 120 over 360 times 22 over 7 times 14 times 14. Weka kwa bracket, you put in bracket, subtract half times 20 times 9.8. You put also like that. Looking at the first part of the question, can we simplify this one? So 0 goes with 0, by 12, 1 by 12, 3. Then this one is by 7, 1, by 7, we get 2. Then we do not have anything that we can simplify. So you can say it is equals to what? This other part you can say by 2, 1, by 2, 10. So let's try to solve this first part here. And you can have the numerator, you can put them in bracket. We have 22 times 2 times 14. Close the bracket. Defined by denominator, we only have 3. So you divide by 3. And then now you click the answer, you get 205.333 centimeter square. Let's look at the other part of the question. Which is 10 times 9.8. So 10 times 9.8, 98 centimeter square. Subtract the 2, we'll have 200. So when you subtract 205.33 from 98, you are going to get 107.33 centimeters squared. And that is now the area of this segment bounded by an angle of 120 and the radius of 14 and a chord of 20 centimeters. Thank you for listening and following my lesson. I said my name is Joel Muthu. You can follow my handles at Dr. Joel Msivi at Instagram, Facebook, YouTube, and TikTok. Remember to follow my works. I'll really appreciate. Make sure you watch all my videos and support me. Thank you very much and have a blessed day. Thank you.